In this lecture, we are going to explore the relationship between pointers and arrays. We have seen these two concepts mixed up quite a few times now, and that was in the context of character array and character pointers, and there was a few things we mixed up between pointers and arrays, and we hope this can be clear now. Now, this is the first thing you need to know about arrays. The array name can be treated as a pointer to the first element in the array. And we can actually take it and store it in a pointer that we initialize, like pscore here, and we can use it as a pointer. If we dereference it, we're going to get the first element in the array. If we print it out, we're going to get the address of the first element in the array printed out. Exactly like we could do with a pointer. It doesn't even stop there. You can even use the angle bracket notation to get an element. Instead of going through the dereferencing operator or the star operator, we had to go through, like here for example, to get the element printed out. This is something you need to keep in your mind. The array name can be treated like a pointer to the first element in the array, but it's not the real pointer. We're going to see a few differences in a few slides, but keep this in mind. We can dereference the pointer to get the element that we want to get, and we can print this pointer to get the address of the first element. Try to look at these examples and try to really understand. If you look here where we say print the address, if we print scores, we're going to get the address printed out because we can treat it like a pointer, and a pointer contains addresses. If we print a pointer, we're going to get an address, and that's what we're going to get here. If we print pscore, this is a pointer, so we're going to get an address here printed out. Now, we have talked about the similarities. Let's talk about the differences between the array name and a real pointer. The first thing is that you can't assign to an array name. You can't make the array name point somewhere else. And in that sense, it really is like a constant pointer, and you can't make it point somewhere else. If you try to do that, you're going to get a weird compiler error, but that's the reason you're going to get that error. You can't make an array name point to something else, or in other words, you can't assign something to an array name. If you do that, you're going to be in bad luck. The next difference is that we can't use a pointer to deduce the size of the array. For example, here we have the array scores. That's the array name. It is an int array, which is going to contain 10 elements. We take the array name and use that to initialize a pointer. This is valid C++. It's going to work. If we try to print the size of the array using scores, that's going to work because this is a proper array name. But if we try to use pscore here, we're going to get a compiler error. And the reason is, pscore is a pointer. It's really not an array name. So by doing the initialization here, we have lost some information on the array. And some of that information is what is used to deduce the size of the array when we do something like std size. So this is the difference you need to keep in mind. This is one. The other is that we can't assign to an array name. If we do that, we're going to get a compiler error. And one thing I should really point out before we head over to Visual Studio Code to play with us is that when you assign an array name to a pointer like this, this is referred to as pointer decay. The array name is going to decay into a pointer, and this is going to make it lose some information, and some of that information is what is even used to deduce the size of the array. That's why we can't do std size pscore here. We're going to get a compiler error if we try to do that. Now that you know about this relationship between arrays and pointers, let's head over to Visual Studio Code and actually play with us. Okay, here we are in our working directory. The current project is pointers and arrays. We're going to grab our template files pretty quick. Let's do that. We're going to put them in place, and we're going to open this in Visual Studio Code. So we go to File, Open Folder. We're going to select the current project, and we are going to put in the code we want to play with. This is exactly the same thing we had in the slides, so I don't want to type all this. We have an int array, which is going to contain 10 elements, and they go from 11 to 20. And we take the array name and assign that to a pointer as an initializer. Again, the array name can be treated as a pointer to the first element in the array. And because it can be treated like a pointer, we can use it to initialize another pointer. The same way we can use an int to initialize another int. That's what we're doing here. And now that we have these things, let's try printing them out. If we print scores, we can treat it as a pointer. So it's going to do what a pointer does. If you print a pointer, it's going to give you an address. This is also going to give us an address. If we print pscore, this is a regular pointer, so nothing new here. We're going to get an address. And if we try to get the content, look at the syntaxes we are using here. We try to dereference scores. What do you think we'll get? We are using the dereference operator on an array name because we can treat it like a pointer. If we try to dereference it, we're going to get 11. If we use the syntax, the angle bracket syntax, we're going to get the first element. This is going to work. We can also do the same thing on this pointer we initialized with our array name. And this is really crazy. Look at this. We're going to dereference it. This is really normal, but we can even use the angle brackets on a pointer and get the first element here printed down. So this hopefully drives the point home that the array name is really like a pointer. It behaves like a pointer, but it's not a full pointer, as we are about to prove in the next few examples. For now, we want to try and run this and see what we get. We're going to bring up a terminal so that we can run this, and we're going to build with GCC. The build is going to go through, no problem. We're going to clear and run Rooster. And we expect to see the addresses of these two guys printed out. And you see that they are the same. So we have initialized our pointer with the array name. So these two things should be pointing to the same addresses. And this is the address of the first element in the array. And we can prove that. Let's try and go here and say stdc out. And say the address of the first element in the array. We can say that like this, and we can print that out. We're going to say address of score, and we're going to grab the first element and print that out. And if we build, we're going to be fine, at least I hope. Let's build. The build is good. We're going to clear and run Rooster, and you see that they are the same thing. Okay, scores contain the address, and it is the address of the first element in our array here. I hope this proves this. And if we print these guys by dereferencing stuff, we're going to get that element printed out. And we have two syntaxes we can use. We can either dereference the array name like we dereference a pointer. That's going to give us the element at that address. We can use the angle brackets notation and treat it like an array. That's going to give us the 11 here. We can also dereference the pointer. The pointer now points to the same location, the first element in the array. So that's going to give us the same element. And we can even use the angle brackets notation on a pointer. And I was amazed in that it gives you a lot of flexibility in how you manipulate your data if the data happens to be stored contiguously in memory like we have with an array. And we're going to be learning about more techniques on how we can do that in the next few lectures. For now, we want to just explore the relationship between pointers and arrays. Now, I hope you have seen this. The next thing we're going to see is that there are differences between pointers and arrays. The first difference is that you can't make an array name point somewhere else. If you try to do that, you're going to get a compiler error. So we have our array name here. It's called scores. And we are setting up a new variable, and we are giving it a value of 21. And we are reusing the pointer we have above defined because we don't want to set up another pointer. We can reuse it, no problem. And we are assigning the address of our number to the pointer. And this works because a pointer, you can make it point somewhere else if it's not a const pointer. But for the array name, if you're trying to do something similar, that's not going to work. You're going to get a weird compiler error. You see that Visual Studio Code is already complaining. If we open the problems tab here, we're going to see a weird error that is really not understandable that much. But we can try and build and see if we have better luck with the compiler. And the compiler is going to say incompatible types in assignment of int pointer to int array. And the message here is that you can't make an array name point to somewhere else. it should always point to the first element in the array. This is the first difference. We're going to go down and look at the second difference, and that's that you can't use a regular pointer with std size. And if you look here, we are trying to do that exactly. We have std size scores. Scores is an array name, so that's going to work because we've seen that this works many times. But if you do std size and pass a pointer, which happens to be pointing to the same address as the array name, the compiler is not going to be happy. Because pscore here, our pointer, is really an array name that has decayed or lost some information. And some of that information is what is used by std size to deduce the size of the array. Let's see the problem we have here. We're going to try and run through the compiler and see the error ourselves. Let's try and clear and run this again. Let's build with GCC. And it's going to give us a lot of output. Okay, by now, you know that you shouldn't use std size with a row pointer. That's going to lead you to disaster. Don't do that. And this is really all we set out to do in this lecture. Doing a few examples to shed some light on the relationship between pointers and arrays. The relationship is really that the array name is like a pointer to the first element in the array, and we can use it like we use a pointer. We can dereference it, and we can do all kinds of crazy things with it. This relationship is actually going to open the door to many more things we can do with pointers and arrays, and we're going to start exploring that starting in the next lecture. Go ahead and finish up here and meet me there.